Hello friends. Welcome back to Cosmic Ways, and today you are gonna learn about the lenticular galaxies, which was not explained in the previous video. So without wasting time, let's begin, but before that, make sure you like and share this video and subscribe to the channel for more updates. A lenticular galaxy, denoted S0, is a type of galaxy intermediate between an elliptical, denoted E, and a spiral galaxy in galaxy morphological classification schemes. It contains a large-scale disk but does not have large-scale spiral arms. Lenticular galaxies are disk galaxies that have used up or lost most of their interstellar matter and therefore have very little ongoing star formation. They may, however, retain significant dust in their disks. As a result, they consist mainly of aging stars, like elliptical galaxies. Lenticular galaxies are often considered to be a poorly understood transition state between spiral and elliptical galaxies, which results in their intermediate placement on the Hubble sequence. This results from lenticulars having both prominent disk and bulge components. The disk component is usually featureless, which precludes a classification system similar to spiral galaxies. As the bulge component is usually spherical, elliptical galaxy classifications are also unsuitable. Lenticular galaxies are thus divided into subclasses based upon either the amount of dust present or the prominence of a central bar. The classes of lenticular galaxies with no bar are S01, S02, and S03, where the subscripted numbers indicate the amount of dust absorption in the disk component. The corresponding classes for lenticulars with a central bar are SB01, SB02, and SB03. Despite the morphological differences, lenticular and elliptical galaxies share common properties like spectral features and scaling relations. Both can be considered early-type galaxies that are passively evolving, at least in the local part of the universe. The distribution for lenticular galaxies rises steadily in the range 0.25 to 0.85, whereas the distribution for spirals is essentially flat in that same range. Larger axial ratios can be explained by observing face-on disk galaxies or by having a sample of spheroidal, bulge-dominated galaxies. Imagine looking at two disk galaxies edge-on, one with a bulge and one without a bulge. The galaxy with a prominent bulge will have a larger edge-on axial ratio compared to the galaxy without a bulge based on the definition of axial ratio. Thus, a sample of disk galaxies with prominent spheroidal components will have more galaxies at larger axial ratios. The fact that the lenticular galaxy distribution rises with increasing observed axial ratio implies that lenticulars are dominated by a central bulge component. So this was all about lenticular galaxies. I hope you enjoyed this video. If you do, then don't forget to like and share it. Until next time, till then, stay safe and unleash your knowledge on astronomy.